Okay, so we'll be discussing some more characteristics on the previous lecture, wherein we saw the reaction of aldehydes and ketones with NH2Z. Okay, so let's write some notes on the same. So uh, in the previous section, we actually saw NH2Z getting attached on the ketones and aldehydes groups with the elimination of water molecule from with the elimination of oxygen atom from the aldehyde and hydrogen atom from the NH2Z group. Okay, so let's write some notes on the same. So the previous reaction or the above reaction gives the best yield at pH of 4 to 5. Okay, so reaction with NH2Z gives best yield at pH of 4 to 5. Okay, second point is 2,4-DNP is a test for aldehyde and ketone. Okay, so 2,4-dinitro phenylhydrazine is a test for, which is also called Brady's reagent. Okay, is a test for aldehyde and ketone, as we saw in the previous lecture that they form colored precipitate of red, orange and yellow color. Okay, so when aldehyde and ketone reacts with primary amine, Schiff's base will form. Third point is when aldehyde ketone reacts with primary amine, Schiff's base which is nothing but this there is a R dash here, not oxygen. Okay, is a Schiff's base will form. Okay, so now let us do some exercises wherein the question is you have to identify the unknowns in the below compounds. Okay, so the first compound we have is this. On reaction with NH2OH in acidic medium forms products A and B. Okay, so what are products A and B? So it is nothing but, again, we will have water molecule separated or leaving the two compounds, oxygen coming from the ketone group or keto group and hydrogen molecule coming from the nitrogen atom. Okay, so we have something like this. Okay, and A would be nothing but we'll have double bond and OH lone pair here and CH3 group here. So another one would be the product B would be geometrical isomer of the product A. Okay, so let us say what will happen in this case. In this case we have NH2OH here and H plus. What would the product in this case? Again, water molecule will be leaving the two compounds. Okay, and we'll get something like this one. Okay, let's see another example. We have product A and B. They, on reacting, product forms product this. So we have to identify compounds A and B. Okay, so obviously we have a double bond between carbon and nitrogen atom. So what will happen is we have double bond means the water molecule would be actually eliminated from this group. Okay, so this has to be on the left hand side of the double bond, or rather on the right hand side of the double bond. This would be the compound, and on the left hand side CHO and PH would be the compound. Okay, So these actually react in acidic medium to form this product. Okay, let's look at another example. We have A plus B products, or compounds rather, reacting, and we are getting this and something like this. So what are A and B? Obviously A and B would be something like, let's go into the reverse direction. This is the double bond, so it must be NH2 here, okay, and it must be double bond here, a keto group here, and this is attached with a phenyl ring. Okay, so this would be the product or compounds A and B. Let's look at another example. Here we have something like this, double bond here, this on reacting with the, so let's say there is no double bond here, so we have something like, so let's go with the double bond. I'll use that another example in the sixth example. So let's say you have to identify the reagent here X and the product Y here. So product Y, product A is not Y, product A is, we have something like this, and NH2 here. So what is X? So X would be nothing but, let's try, if we have H plus in H plus in water, so what will take place is, we will have something like this double bond will go and actually the double bond between the carbon atom and nitrogen atom would be broken, and the lone pair of nitrogen atom will be getting attached with the H, okay, and we will have a positive charge here. So OH will get attached to the positive charge, we'll get something like this, okay. Next what will happen is, the oxygen atom would actually, or rather let's see this like this, that we have the acidic medium and this is a good base, okay. So what will happen is, the lone pair will again attack on the H plus, and as a result we'll be getting something like NH2 here and positive charge on this nitrogen atom, and OH is also attached here. So what will happen is, this nitrogen atom will take away the bond electrons with itself and the neighboring carbon atom, and will get something like a positive charge here, OH attached here, and NH2 here. Then next what will happen is, H plus would be getting released from the compound, and the lone pairs on oxygen atom would be forming double bond with the neighboring carbon atom. Hence we'll be getting something like a aldehyde and this group, okay. Let's take another example. We have something like this, and this on reacting with, what is this compound called? This is called hydrazine, okay. And what would be the compound which would be formed as a product? That would be called hydrazone. We have seen this in the previous lecture, wherein when we use 2,4-DNP, which was 2,4-dinitrophenylhydrazine, we got 2,4-dinitrophenylhydrazone, okay, which was a raw colored PPT. But in this case no 2,4-DNP is there. So what will happen is, first both the two oxygen atoms will react with this hydrogen atom, and the second one will react with this hydrogen atom. As a result we will be getting something like this compound, okay, and these two were already connected with this bond. Next what will happen is, nothing would happen, because this is the final product we will be getting, because this is a hydrazone we have already got, okay, and this is cyclic. So this is a cyclic hydrazone, okay. So let's see what actually happens in this case when we actually react again a similar compound. In this case it's a ketone group. So what will happen in this case is, again we have NH2 or hydrazine. Again this O will attack on this hydrogen atom, and this O will attack on this H2. Again you can call it hydrogen or H2, because ultimately water molecule would be released. So we'll be getting something like double bond N here, double bond N here, and these two nitrogen atoms were already previously connected with each other. Okay, so next a good question is coming your way, in which we have to write the mechanism as to how this compound on reacting with 2-degree amine, this is 2-degree amine, okay, in acidic medium formed this compound. Which is nothing but a enamine. Okay, I actually introduced the word for the first time. Okay, so this product is called enamine. Okay, so how does the mechanism takes place? So I'll just pause the video for 2-3 minutes, bring a pen and paper, do all the required steps and get to the solution. So I hope you will be playing this video after you have at least tried it one time before getting to know the solution, but still it's my job to give you the solution. So let's get started. So again what will happen is, this lone pair will actually attack on this carbon atom, and as a result we'll be getting this as an intermediate. Okay, OH here, N plus H, and this ring here, 5-membered ring here. So now what will happen is, we'll get something like this. Hydrogen atom would be taken back, the lone pair of hydrogen atom would be taken back by the nitrogen atom, and then when we heat this, what will happen is, there is a alpha hydrogen also on the alpha hydrogen related to this carbon atom, okay, which has a H attached. So on heating, the hydrogen molecule would attach itself with the OH molecule, and leaving a minus sign here and a positive charge here, thereby we can form a bond at this position. Okay, so this is the final answer which we will get after the following reaction took place. Okay, so that was a easy mechanism. Okay, I hope all of you would be able to get it right the first time. Okay, so before ending this lecture, let's see the last example. So here we have something like this compound. Okay, chloride here and ester group here, and we are reacting it with hydrazine. So what will happen? So obviously this would act as a nucleophile for this carbon atom and for this carbon atom. As a result, we'll be getting something like Cl and OAT would be leaving, and on the same side NH, single bond NH, would be replacing their respective positions. Okay, so this is the final product which we get. Okay, so this brings us to the end of this lecture. In the next lecture, we'll be seeing some more examples of reaction of aldehydes and ketones with some other interesting reagents, and then we'll be seeing some aldol condensation and concepts like that. Okay, so till then, good luck and goodbye.